Welcome to network security demonstration. Before we start with the security part of the networks, let's understand how computer network operate. What we are going to do now is we'll have a look at what an internet protocol header looks like and then quickly capture a packet and practically verify the values in the internet protocol header. So let's start. This is how your internet protocol header will look like. The first field, version, will talk about the IP protocol version. That is, it can be either 4 or either 6. There are two well-known versions being used in the market. One is version 4 that is being widely used today, and another is version 6. Next field in the IP protocol header is header length, internet header length. This header length will only talk about some starting parameters and will not talk about the data or the payload attached to this IP packet. Next field is of 8 bits, which talks about type of service. This is pertaining to the quality of service that my IP protocol is trying to provide. Next comes is the 16-bit length field. Now this length field will talk about the whole IP packet length, meaning that it will talk about the data or the payload that is being attached. Next comes the identification field. The identification field is 16-bit long, and then it is used for reassembling the different fragmented packets, meaning that if the data is sent in different smaller units called as fragments, this identification field will be very helpful for my receiving host in order to rearrange the IP packets and reorder the data. Next 3 bits will talk about IP flags. These flags will again talk about the fragmentation part of the IP header, whether my packet needs to be fragmented, whether there are any more fragments coming, so on and so forth. Then comes the fragment offset part. This field will talk about the fragment offset. Next 8 bits will talk about time to live. TTL is the field which refers to the life of the packet. As soon as this TTL value goes 0, the packet will be removed from the network. Next field is talking about the protocol. IP protocol hosts different services or different protocols on the above layer, that is upper layer, that is transport. So this protocol field will let me know what type of traffic that is being carried by my IP packet, whether it is TCP, UDP or ICMP. Then comes the header checksum field. Header checksum field will talk about error control, and this will have the checksum value of my IP header. If this checksum verification fails, then my host will simply drop the IP packet saying that it is containing some error. Next 32 bits will talk about the sender's IP address, and next 32 bits will talk about the destination or the receiver's IP address. After that, there are some configurable options, but which are not used regularly. So this forms your internet protocol header. We can use one tool called Wireshark. It's an open source software, or you can call it as a free software, which is widely used for study of different protocols. So let's quickly start Wireshark and start verifying the IP protocol headers. This is how your Wireshark software will look like when you have installed the software. In order to verify different protocol headers, what we need to do is simply when I click on this button, I get this capture window. So what I'm going to do next is I'm going to start command prompt and then I'll start capturing packets. If I select the first packet, let me verify the different values in it. See, Wireshark directly gives you what is the protocol and what are the values. Let me have a quick look at what my internet protocol header looks like. When I click on version 4, it will give me this first 4 bits value, that is version 4. Then comes the 20 byte which is designated by value 5. Then comes the type of service field. Then comes the total length field which can be seen here in hexadecimal values. Then comes the identification field which can be seen as a 16-bit field here. Then comes the flags part. As there is no fragmentation, all values are 0, there are no fragments. Fragment offset, as there are no fragments, we can see this value 0. Default TTL value can be seen as 128. The difference between the values is observed simply because the value 80 is a hexadecimal value and value 128 is decimal value. Then comes the type of protocol, which is 17 or 17 in this case, which is represented as 11 in your hexadecimal. Then comes the header checksum part. Header checksum is again 16-bit field. Then comes your source IP address, which is of 32 bits. Then comes the destination address part, which is of 32 bits. So I think we have verified what actually is an IP header, what values it can contain, and I think it matches to the diagram that we have seen, isn't it? Okay, have a nice day and continue studying network security. It's very interesting topic. Bye bye.